Hi everyone, thank you so much for coming to this video. So today we're going to be going over correlation and regression lines. So the learning objective for today is going to be able to interpret scatter diagrams and regression lines for bivariate data, and to be able to understand the informal interpretation of correlation and that it does not imply causation. So reviewing the video on straight lines and what the gradient and intercept is and how to find that would be useful for this video, as we will cover this a little bit. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So firstly, you just need to know what a scatter diagram is. So scatter diagrams are ones that show the relationship between two variables. And we quite often explain this or describe this relationship using the term correlation. So correlation is just suggesting whether there's any relationship between the two variables. So there are different types of instances and types of correlation that you can have, and the type of scatter diagram that you would see, which shows these correlations. So the first one here we have is a positive correlation. And this is normally when you see your crosses going in an upwards direction, and a positive correlation normally means the more as X increases, Y also increases. So for this example here, we have as more sunglasses are sold, there are more ice cream sales. So that's what a positive correlation is. And you could normally have a line of best fit that can put all the dots that connect all your dots, all your scattered diagram dots. So if this line of best fit is a positive, is upward sloping with a positive gradient, then that normally means you have a positive correlation. And there are different types of correlation you can have. You can have either a weak correlation or a strong correlation. So a weak correlation is normally if you draw your line of best fit, there are less of your crosses on that line, but if there's a strong correlation, then it would mean most points of your line, most points of your scatter diagram will be on your line of best fit. So for example, let's say you have a line of best fit like this, then a weak correlation would have something like only a few of them would be on the dot, but you still have an overall upward positive sloping regression line. There's an overall relationship that the more X the more of the X value there is, the more of the Y value. And so this line of best fit that you can have, that can also be, that's also called your regression line. So it's also called regression line. And that's normally in the form Y equals AX plus B that I've written here. So this line here is in the form Y equals AX plus B. And your A, that represents your gradient. And you can, if you're asked in a question to talk about your gradient, applying it to the context your scatter diagram is in, then your gradient represents if you increase your X value, your X by X amount, by some amount, how much would your Y value increase? So if you increase the number of sunglasses by 1, how much would your ice cream sales increase by? That's what your gradient, that's what your A or your gradient represents in your line of best fit or your regression line. Your B, that represents your y-intercept, so where your regression line touches your y-axis. So this is how much of your y value you would have if you have 0 X value. So if you apply to this context with sunglasses sold and ice cream sales, you'd have how many ice cream sales would there be when there are 0 sunglasses sold. So that's an overview of positive correlation and how you can use your line of best fit and your regression line. The next type of correlation you can have is a negative correlation. And this is where if you were to draw a line, your line of best fit through your points on your scatter diagram, you'd have a negative sloped line, so downward slope. So a negative correlation is as you increase your, as X increases, your Y decreases. So that's what a negative correlation is. Again, you could have a weak negative correlation or positive correlation. The positive correlation being more of your points on your scatter diagram are on the line, your weak being less on your line. And in terms of your y-intercept and gradient, for negative correlation, you're going to have a negative A value, a negative gradient, and this is saying as you increase your x by a unit, how much would your y unit decrease by? So that's what a negative correlation is. Next, we have no correlation, and this is you can't have any line of best fit through your scatter diagram. There is like no correlation that you can see in your diagram. So that's what no correlation is. Next, so that's all the three types of correlations, and what your line of best fit would look like, and how you can interpret your A and B from your regression line. Well, last thing that you do need to be careful about is if you have like two clusters on your scatter diagram, like we have in this example. So here, overall, it shows there's like a negative correlation because you can kind of draw a line like that. It's like a very weak, but there is a negative correlation there. But then within your two clusters, you have no correlation within them. So you have to be quite careful with this kind of diagram, because overall, you can see a negative correlation, but within your clusters, you have no correlation whatsoever. One last thing, even though your diagram may show you have a positive or negative correlation, one really important thing you need to remember that is correlation does not necessarily imply causation. So with your sunglasses sold and ice cream sales, you can see a strong positive correlation. As more sunglasses are sold, there are more ice cream sales. But if you think about that, there's no way, you can't really, it's not necessary that actually more sunglasses sold is leading to more ice cream sales. There's no direct causation between the two. There could be a third factor in there that's causing it. So like the weather. So like as it's more sunny, more sunglasses are sold, and also there are more ice cream sales. But that's not directly linked. There's no direct link between sunglasses sold and ice cream sales. So remember that. Really important, correlation does not necessarily imply causation. There may be a third factor that's causing your correlation that you see on your graph. So that's really everything you need to know about scatter diagrams, correlation, and your regression line. So let's put this into practice. So we have an exam style question here. Feel free to pause the video and try it out for yourself first. So we have a football coach measured the height and weights of 12 players. The data is shown below. So the first thing is we want to draw a scatter graph for this information. So you can just use some graph paper, and if you plot all your points out, you should get something like this. So let me just make it bigger. So this is how your scatter diagram should look like. So have a go plotting this on graph paper yourself. Part B, you want to give an interpretation of the correlation between the height and weight of footballers. So you can see that there is a positive correlation. It does seem that as height increases, weight also increases. So we can say positive, as height increases, weight also increases. So part C, we have the equation of the regression line is W equals 1.37H minus 173. We want to give an interpretation of the gradient of this regression line. So the gradient is 1.37. So this, we can say that for every centimeter height increases by your weight increases by 1.37 kilograms. Yeah, because gradient measures like the change in y with the change in x. So for every centimetre that height increased, your weight would increase by 1.37. Because gradient is just change in y, which is 1.37, over change in x, which is just 1 centimetre. So you'd get 1.37. Part D, we want to use the equation of the regression line to estimate the weight of a player who is 170 centimetres tall. So we can just plug that in. So we'd have weight is equal to 1.37 times 170 minus 173. And if you plug that into a calculator, you should get that is equal to 59.9 kilograms. Part E, we want to comment on the reliability of your estimate in Part D, giving a reason for your answer. So we can say that our estimate is reliable because 170 centimeters is in with our range, because we have a range to 200 centimeters. So it is reliable as 170 centimeters is within range tested. So that means that our regression line that we found is relevant for 170 centimeters. So yeah, that's our answer to this question. So it's just knowing like how to describe a correlation in a context of the question, and how you describe your gradient and y-intercept of your regression line, again within your context of your question, and also knowing whether your estimate is reliable or not. So normally, if the value that they have, like they want you to use to find another variable, so they've said 170 to find your weight, if that is within the range of data values that you have, then it's normally reliable. But let's say they were asked you to find the weight when the height is 210 centimeters. That's outside the data that we've tested. So that would mean that it's not that reliable, as you're like extrapolating your data. You're like using your regression line beyond the values that is actually tested for and known for. So whenever you have your variable that's within your data range, it will be reliable. When it's outside your data range, it won't be reliable. So let's try one more question. So you have another question here. Again, feel free to pause the video and try it out for yourself first. So we have Ross did an investigation into the relationship between study into temperature T and total hours of sunshine S at Heathrow. He finds that the equation of the regression line is S equals 0.25T plus 1.3. So we want to give an interpretation of the figure 0.25 figure in this regression line. So 0.25 is your gradient of your regression line. So that's just saying as for this regression line, you have T as your X and you have S as your Y. So it says, so you can interpret 0.25 by saying for every degrees temperature increased by total hours of sunshine increases by 0.25 hours. So it's an increase because we have a positive regression line, a positive correlation, as your gradient is positive. If it was negative, it would be for every degrees temperature increases by, your total hours of sunshine would decrease. But because it's just 0.25, everything's positive. It's for every degrees temperature increases by, your total hours of sunshine would increase by 0.25 hours. So again, just knowing how to interpret your gradient for the regression line in the context of what the question is saying. that's everything. Thank you so much, everyone. Hope you found that useful, and you can now interpret scatter diagrams and regression lines for bivariate data, and you understand the informal interpretation of correlation and that it does not imply causation. So make sure you do some practice questions just to make sure you can fully apply everything that we've learned in this video.